In this video, we'll be learning part 2.5 Algebraic Identities of Chapter 2 Polynomials of Class 9 CBSE. We'll also be solving exercise 2.4 questions from the NCERT textbook. An algebraic equation that is true for all values of variables occurring in it is an algebraic identity. We know that an expression usually has variables like x and y. So we call an algebraic identity true for any value of x and y. Let us take a look at some identities. Identity 1 is x plus y whole square equals to x square plus 2xy plus y square. You might have seen this identity before in the form of a plus b whole square, a square plus 2ab plus b square. That's the same formula here. Identity 2 is x minus y whole square, which is x square minus 2xy plus y square. Identity 3, x square minus y square equals to x plus y into x minus y. Identity 4 says x plus a into x plus b equals to x square plus a plus b into x plus ab. So all these identities will be true for any given value of x and y. For example, if you're given a value of x minus y whole square, you will be able to find the value of this by substituting the value of x and y on the right hand side. These identities will be true for all given values of x and y. If you have the values of x and y and you have to find the value from the left hand side, you simply need to substitute the values in the right hand side and the answer will be the same. Now that we have learned the first 4 identities, let us take a deeper look at rest of the 4 identities that we need to know. Identity 5 is x plus y plus z whole square equals to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. This identity can be used to solve problems like this. For example, here we are asked to factorize 4x square plus y square plus z square minus 4xy minus 2yz plus 4zx. This is in the form of the 5th identity. Using this identity, I can write this as 2x whole square plus minus y whole square plus z square plus 2x into minus y plus 2 into minus y into z plus 2 into 2x into minus y plus 2 into minus y into z. Now, using identity 5, I can write this as 2x whole square plus minus y whole square plus z square plus 2 into 2x into minus y plus 2 into minus y into z plus 2 into z into 2x. This can be written as 2x minus y plus z whole square. This is how we can solve problems like this using identities. Identity 5 can be used to solve different kinds of sums. For example, here we have a question asking us to factorize the given expression. Now this expression looks very similar to identity 5. So in order to factorize, that is to write this expression in terms of its factors, we can write it as x plus y plus z whole square. In order to write that, let's isolate x and y and z based on the identity 5. We can write it as given here in terms of x can be 2x, y can be minus y, z can be z. Here we can see that minus 4xy can be written as 2 into 2x into minus y, minus 2yz can be written as 2 into minus y into z, and 4zx is nothing but 2 into z into 2x. Now this can be written in terms of x plus y plus z whole square. After writing, I get 2x minus y plus z whole square. So now we have factorized this. In this case, factors are nothing but 2x minus y plus z into 2x minus y plus z. So this is how we can use identities in order to factorize the given expressions. Identity 6 is x plus y whole cube. X plus y whole cube equals to x cube plus y cube plus 3xy into x plus y. Identity 7 is similar, but it is x minus y whole cube. X minus y whole cube is x cube minus y cube minus 3xy into x minus y. Let's take a look at an example where we can use these kind of identities in order to solve a problem. We are asked to evaluate 102 whole cube. Here, in order to expand this, we don't have to do 102 into 102 into 102. That will be complicated. Instead, I can use the identity and write 102 as 100 plus 2 whole cube. Upon expansion, I can use the identity 6 and write 100 cube plus 2 cube plus 3 into 100 into 2 into 100 plus 2. Upon expansion, this will become 10 lakhs, this will become 8 and this will become 600 into 102, which can be further written as 10 lakhs plus 8 plus 61,200. Here I have multiplied 600 into 102 and the final answer will be 1061208. Let's take a look at another example which is similar, but we will use identity x minus y whole cube. Here the question is evaluate 97 whole cube. I can write 97 as 100 minus 3 whole cube. Now this is of the form x minus y whole cube. So I can write this in form of x cube minus y cube minus 3xy into x minus 5. Upon writing it, I have x as 100 and substituted y as 3. Upon further expansion, I expand 100 cube, 3 cube is 27, 3 into 100 into 3 is 900 and 100 minus 3 is 97. Upon solving this, I get the answer of 999,100. The last identity that we have to learn is x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. We can use this identity in order to factorize an example that's given here, which is 8x cube plus y cube plus 27z cube minus 18xyz. Now this is of the form x cube plus y cube plus z cube minus 3xyz. Here x is nothing but 2x, y is y and z is 3z. Upon using the identity and expanding further, I can write it as 2x plus y plus 3z into 2x whole square plus y square plus 3z whole square minus 2xy minus 3zy minus 3z into 2x. Now I can further simplify this into 2x plus y plus 3z into 2x whole square is 4x square plus y square, 3z whole square is 9z square minus 2xy minus 3yz, 3 into 2 6 and x into z. This is how I can factorize a complicated problem by using the identity. Let's start solving exercise 2.4 question using the identities that we just learned. First question asks us to solve the following using suitable identities. First one is x plus 4 into x plus 10. This is of the form x plus a into x plus b. Here I am going to use the identity x plus a into x plus b equals to x square plus a plus b into x plus ab. Here a is 4 and b is 10. Upon substitution, I can write this as x square plus 4 plus 10 into x plus 4 into 10. Now upon further expansion, I get the answer as x square 4 plus 10 is 14 and 4 into 10 is 40. So x square plus 14x plus 40. The second one is x plus 8 into x minus 10. This is also of the form x plus a into x plus b. Let us identify a and b and use the identity here in order to solve it. A can be written as 8 and b is minus 10 because x plus a into x plus b, but here we have minus 10. So we take b as minus 10. Upon substituting in this identity here, I get x square plus a plus b is 8 plus minus 10 into x plus 8 into minus 10. This can be written as x square plus 8 minus 10 because plus into minus is minus and 8 minus 10 into x minus 80. So it will become x square minus 2x minus 80. Third question is 3x plus 4 into 3x minus 5. Again using the identity x plus a into x plus b. Here a is 4, b is minus 5 and x is 3x. Upon substituting these values in our identity here, I get 3x whole square, that is x square, 4 plus minus 5, a plus b into x, that is 3x, plus a into b, that is 4 into minus 5. Upon further simplification, I get 9x square, 4 minus 5 is minus 1 into 3x and 4 into minus 5 is minus 20. I can write this as 9x square minus 3x minus 20. Fourth one is y square plus 3 by 2 into y square minus 3 by 2. This is in the form of x plus y into x minus 5. Here I will be using the identity x plus y into x minus y equals to x square minus y square to simplify this. Now x square is nothing but y square whole square and y square is nothing but 3 by 2 whole square. Upon further simplification, I can write y square whole square is y power 4 minus 3 by 2 whole square is 3 square by 2 square, and this will become y power 4 by 9 minus 4. Fifth question is 3 minus 2x into 3 plus 2x. This is again of the form x plus y into x minus 5. Here x is 3 and y is 2x. Using the identity x plus y into x minus y equals to x square minus y square, I can write this as 3 square minus 2x whole square. 3 square is 9 and 2x whole square is 4x square. In the second question of exercise 2.4, we have to evaluate the following products without multiplying directly. I have to find the value of 103 into 107 without direct multiplication. Using our identities, we can write this as 100 plus 3 into 100 plus 7. Now this is in the form of x plus a into x plus b. Here x is 100 and a is 3 and b is 7. Using the identity x plus a into x plus b equals to x square plus a plus b into x plus ab, I can write this as 100 square plus 3 plus 7 into 100 plus 3 into 7. Now further it can be written as 10,000 plus 10 into 100 plus 21. Upon the addition of all the products, I get the answer as 11,021. Second one is 95 into 96. Again, I have to find the product without direct multiplication. So I am going to write it as 100 minus 5 into 100 minus 4. Here, again this is in the form of x plus a into x minus b, where x is 100 and a is minus 5 and b is minus 4. Bringing back my identity x plus a into x plus b and substituting the values gives me 100 square plus a plus b is minus 5 plus minus 4 into 100 plus a into b is minus 5 into minus 4. Now upon expanding, I get 10,000 minus 9 into 100 plus 20. Upon further expansion and simplification, I get the answer as 9,100 minus 20, which is 9,080. Third one is 104 into 96. Again, I can write this as 100 plus 4 into 100 minus 4. This is in the form of x plus y into x minus y. Taking the identity x plus y into x minus y equals to x square minus y square, I can write as x is 100 and y is 4. So 100 square minus 4 square, which is 10,000 minus 16. That gives me the answer 9,984. In third question, we'll factorize some of the given questions using identities. First one is 9x square plus 6xy plus y square. This looks like x square plus 2xy plus y square. Writing it in the form of the identity, I can write as 9x square can be written as 3x whole square plus 2 into 3x into y plus y square. Now we know that x square plus 2xy plus y square is x plus y whole square. So I can write this as 3x plus y whole square. Second one is 4y square minus 4y plus 1. This is in the form of x square minus 2xy plus y square. Let's write this in the form of this identity. So here I can write x square as 2y whole square and minus 2xy as minus 2 into 2y into 1, and 1 can be written as 1 square. So now this is in the form of the identity x minus y whole square equals to x square minus 2xy plus y square. So I can write it as second one is 4y square minus 4y plus 1. This looks similar to the identity x square minus 2xy plus y square. Trying to write this in this form, I can write it as 2y whole square minus 2 into 2y into 1 plus 1 square. Here x is 2y and y is 1. So I can write this as 2y minus 1 whole square. Third one is x square minus y square by 100. This is of the form x square minus y square. Here x is x and y is y by 10. Because 10 square is 100, here I can take y as y by 10 and y square will be y square by 100. Using the identity x plus y into x minus y equals to x square minus y square, I can factorize this in terms of x plus y into x minus y, which is x square minus y square, which is x plus y by 10 into x minus y by 10. Fourth one asks us to expand the given expressions using identities. First one is x plus 2y plus 4z whole square. This looks similar to x plus y plus z whole square, where x is x, y is 2y and z is 4z. Let's bring the identity x plus y plus z whole square and substitute the values in order to expand the given expression. Upon expansion, I can write x square plus y square plus z square plus 2xy plus 2yz plus 2zx by substituting our values. Upon further simplification, this becomes x square, 2y whole square becomes 4y square, 4z whole square becomes 16z square, 2 into x into 2y is 4xy, 2 into 2y into 4z is 16yz, and 2 into 4 8zx. So this is the expanded version of the given expression. Second question is 2x minus y plus z whole square. This is also of the form x plus y plus z whole square. However, here x equals to 2x, y is minus y, and z equals to z. Again, using the identity x plus y plus z whole square, I can expand this as shown here. Here I have substituted x value as 2x, y value as minus y, and z value as z. Upon further simplification, this becomes 4x square plus y square plus z square minus 4xy minus 2yz plus 4zx. Next question, 1 by 4a minus 1 by 2b plus 1 whole square. This is also of the form x plus y plus z whole square. Here x is 1 by 4a, y is minus 1 by 2b, and z is 1. Using the identity for x plus y plus z whole square, I can expand this and write as 1 by 4a in the place of x, minus 1 by 2b in the place of y, and 1 in the place of z, and expand as shown here, which can be further simplified as 1 by 16a square plus 1 by 4b square plus 1 plus, here 2 and 2 gets cancelled. I am left with 1 by 4a into minus b. Here 2 and 2 get cancelled, so I am left with minus b. Here I can write as 2 1s are 2 2s are, so I am left with 1 by 2a. And on further simplification, this can be written as a square by 16 plus b square by 4 plus 1 minus ab by 4 minus b plus a by 2. Fifth question asks us to factorize using identities. First one is 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Here I can use the identity x plus y plus z whole square. Upon using the identity for x plus y plus z whole square, I can write this as, here I can take a look at x plus y plus z whole square and the expansion of the identity and try to write the given expression in the form of this expansion. Here I can write as 2x whole square instead of x square. I can write 9y square as 3y whole square instead of y square. I can write 16z square as minus 4z whole square in the place of z square. Here I have taken minus 4z whole square in order to write the 16z square, because I can notice that the terms that have z are having minus in them. So that's the reason I have taken minus 4z whole square. Plus again, in the place of x, y and z, I have substituted 2x, 3y and minus 4z and written the rest of the expression. So now I can factorize this whole expression as 2x plus 3y minus 4z using the identity. You can further write it in terms of factors in this form, where you can expand the square and write 2x plus 3y minus 4z into 2x plus 3y minus 4z. So this is how we can factorize using an identity. Second one is 2x square plus y square plus 8z square minus 2 root 2 xy plus 4 root 2 yz minus 8xz. This is also in the form of identity x plus y plus z whole square. The first step is try to write this expression given to us in terms of the right hand side expression in the identity in order to identify x, y and z. Upon writing it, it looks like this. Here I have written 2x square as x square by taking root 2x whole square. Similarly, I have written z square as 2 root 2 z square. That is because 2 root 2 whole square is 8. I have assigned the negative sign to x here because the terms with x are negative here. Now I can identify x as minus root 2x, y as y and z as 2 root 2z. And now writing in the terms of identity, I can write as minus root 2x plus y plus 2 root 2z whole square. If you want to further expand this in terms of factors, you can also write square root 2x plus y plus 2 square root 2z into minus square root 2x plus y plus 2 root 2z. Sixth question asks us to expand the following cubes. First one is 2x plus 1 whole cube. This is in the form of x plus y whole cube, where x is 2x and y is 1. Let's use the formula for x plus y whole cube and expand the given cube. Here, upon substituting x as 2x and y as 1, I can expand this as 2x whole cube plus 1 cube plus 3 into 2x into 1 into 2x plus 1. Upon further expansion, I can write this as 8x cube plus 1, 3 into 2, 6, that is 6x into 2x plus 1. Expanding it again gives me 8x cube plus 1, 6x into 2x is 12x square and 6x into 1 is 6x. I can now write this as 8x cube plus 12x square plus 6x plus 1. Second one is 2a minus 3b whole cube. This is in the form of x minus y whole cube where x is 2a and y is 3b. Let's substitute x as 2a and y as 3b in the formula for x minus y whole cube, which is x cube minus y cube minus 3xy into x minus y. Substituting it gives me 2a whole cube minus 3b whole cube minus 3 into 2a into 3b into 2a minus 3b. Expanding it further gives me 8a cube minus 27b cube minus here 3 into 2 6, 6 into 3 18 and into a into b into 2a minus 3b. Now upon further expanding, I can write this as 8a cube minus 27b cube. Here 18ab into 2a is 36a square b, 18ab into 3b is 54ab square. Third one is 3 by 2x plus 1 whole cube. This is in the form of x plus y whole cube where x is 3 by 2x and y is 1. Let's substitute the x and y values in the formula for x plus y whole cube and I get 3 by 2x whole cube plus 1 cube plus 3xy, that is 3 into x into y into x plus y. Now simplifying this gives me 3 by 2x whole cube is 27x cube by 8 plus 1. Here 3 into 3 is 9 by 2x and 3 by 2x plus 1. Now I have to further expand this. I get 27x cube by 8 plus 1. Here 9 into 3 is 27x square. 2 into 2 is 4. Again 9 by 2 into 1 is 9 by 2. X into 1 is x. I can rearrange this and write as 27 by 8x cube plus 27x square by 4 plus 9 by 2x plus 1. Question 4 in the sixth question is x minus 2 by 3y whole cube. This is of the form x minus y whole cube where x equals to x but y equals to 2 by 3y. Substituting these values in x minus y whole cube gives me x cube minus 2 by 3y whole cube minus 3x into 2 by 3y into x minus y, which is x minus 2 by 3 into y. Now simplifying it is going to give me x cube minus 8y cube by 27 minus 2x square y, minus into minus will become plus and 2 into 2 is 4, 4 by 3 xy square. Seventh question asks us to evaluate using suitable identities. First one is 99 whole cube. Here I cannot multiply 99 into 99 into 99 because I have to use an identity. How to do that? I can write 99 as 100 minus 1. So I can write 99 cube as 100 minus 1 whole cube. This is in the form of x minus y whole cube. Here x is equal to 100 and y equals to 1. Substituting these values in x minus y whole cube gives me 100 cube minus 1 cube minus 3 into 100 into 1 into 100 minus 1. Expansion and simplification of this will give me 9,70,299. Second one is 102 whole cube. We have solved this before. We can write 102 as 100 plus 2. Now I can write 102 whole cube as 100 plus 2 whole cube, which is in the form of x plus y whole cube. Taking the formula for x plus y whole cube and substituting x as 100 and y as 2 will give me 100 cube plus 2 cube plus 3 into 2 into 100 into 100 plus 2. Upon expansion and further simplification, I get 10 lakhs plus 61,208, which will give me 10,61,208. Third question is a similar one, which is 998 whole cube. I can write 998 as 1000 minus 2. So I can write 998 whole cube as 1000 minus 2 whole cube, which is in the form of x minus y whole cube. I can substitute x as 1000 and y as 2 in the x minus y whole cube identity, and I can write it as 1000 cube minus 2 cube minus 3 into 1000 into 2 into 1000 minus 2. I can expand and simplify this further in order to get 1 million minus 5,98,808, which will give me the answer 994011992. Eighth question asks us to factorize each of the following. First one is 8a cube plus b cube plus 12a square b plus 6ab square. Now this is very similar to x plus y whole cube, which is x cube plus y cube plus 3x square y plus 3xy square. Here x cube is 8a cube. So I can write 8a cube as 2a whole cube, which will give me x equals to 2a. Y is equal to b. I can also verify 12a square b and 6ab square here. So if x was 2a and y was b, 3x square y should be 3 into 2a whole square into b, which is 3 into 4a square into b, which is 12a square b. So 3x square y is also verified. Similarly, you can verify 3xy square as 3 into 2a into b square, which will give you 6ab square. Now I can write this as 2a plus b whole cube in the form of x plus y whole cube. You can further expand it and write as 2a plus b into 2a plus b into 2a plus b, which will complete the factorization of the given expression. Second question is similar to the first one, but we have a negative sign, which is 8a cube minus b cube minus 12a square b plus 6ab square. I can write this in the form of x minus y whole cube, where x cube is 8a cube, which will give x as 2a and y as b. So I can write this as 2a minus b whole cube. Third one is 27 minus 125a cube minus 135a plus 225a square. This is also in the form of x minus y whole cube, which can be written as x cube minus y cube minus 3x square y plus 3xy square. Here x cube is 27. So I can write x cube as 3 cube, which will give me the value of x as 3. I can write y cube as 125a cube. So y cube can be written as 5a whole cube and y can be written as 5a. Verifying for the value of 3x square y, I am substituting the value of x and y into 3x square y and I get 135a, which is similar to the value I have here. Now verifying for 3xy square, I can write 3 into 3 into 5a whole square, which gives me 225a square, which is also verified. Now I can confidently say that this expression is in the form of x minus y whole cube, where x is 3 and y is 5a. So I can write this as 3 minus 5a whole cube. Upon further expansion, this can also be written as 3 minus 5a into 3 minus 5a into 3 minus 5a. Fourth question is 64a cube minus 27b cube minus 144a square b plus 108ab square. This is also in the form of x minus y whole cube, which is x cube minus y cube minus 3x square y plus 3xy square. Here x cube is nothing but 64a cube. I can write this as 4a whole cube. So I get the value of x as 4a. Now y cube is 27b cube. So y cube can be written as 3b whole cube. So I can say that y is 3b. Let's verify 3x square y with these values. So 3 into 4a square into 3b is giving me 144a square b. So that is verified. Verifying 3xy square and substituting 4a and 3b, I get 108a square b, which is also verified as 3xy square. So now I can write this whole expression as x minus y whole cube, which gives me 4a minus 3b whole cube. Now you can further expand it and write it in factors as 4a minus 3b into 4a minus 3b into 4a minus 3b. Fifth one is 27p cube minus 1 by 216 minus 9 by 2p square plus 1 by 4p. Here I can again write it in the form of x minus y whole cube. To find x, I can write x cube as 27p cube and I can write 27p cube as 3p whole cube. So x will be 3p. Y cube here is 1 by 216. So you have to think of a number whose cube is 216. I know that 6 cube is 216, so I can write this as 1 by 6 whole cube. Now y will be 1 by 6. It is better to verify for 3x square y and 3xy square values, and upon verifying 3x square y, I can write as 3 into 3p whole square into 1 by 6. So I can cancel this, 3 ones are 3 twos. So 3 square is 9, so 9p square by 2, which is what is given here. Now verifying for 3xy square, I can write 3 into 3p into 1 by 6 whole square. So 3 into 3 is 9 and 6 square is 36. Again 9 ones are 9 fours are will be leaving me with p by 4, which is 1 by 4p. So I have verified this and I can write this expression in terms of x minus y whole cube, where x is 3p and y is 1 by 6. So I can write this as 3p minus 1 by 6 whole cube, or 3p into 1 minus 6 into 3p into 1 minus 6 into 3p into 1 minus 6. First question in question number 9 asks me to verify x cube plus y cube equals to x plus y into x square minus xy plus y square. So I need to prove that left hand side is equal to right hand side. Let me start by expanding the right hand side. So here I have to multiply x with x square minus xy plus y square. Then I have to multiply y with x square minus xy plus y square. Now upon further expansion, I have to multiply x with x square, that is x cube, x with xy, that is x square y, x with y square, that is xy square. Again taking the sign as positive here, x square into y is x square y into minus xy is minus xy square, y into y square is y cube. Now I can see that I have minus x square y and plus x square y which get cancelled. I have plus xy square minus xy square that cancel. So I will be left with x cube plus y cube, which is equal to my left hand side. So we have proven that this expression over here can be simplified into x cube plus y cube. Let's take a look at the second question, which is x cube minus y cube equals to x minus y into x square plus xy plus y square. And further expansion needs to be done, where x needs to be multiplied with x square, giving me x cube, x into x square y plus x square y, x into y square is xy square. Here I have a negative sign, so minus y into x square is minus x square y, minus y into xy is minus xy square, minus y into y square is minus y cube. So here I have a positive x square y, negative x square y, positive xy square, negative xy square. I am left with x cube minus y cube, which is again equal to the left hand side that is given to us. So we have proved that simplification of this expression is going to give us x cube minus y cube. 10th question asks us to factorize some expressions, but take the hint as question number 9. First one is 27y cube plus 125z cube. So from question number 9, I can remember that x cube plus y cube is equal to x plus y into x square minus xy plus y square. So I can write this in terms of x cube plus y cube, and where x cube is 27y cube and y cube is 125z cube. Now I can find x and y here as 3y and 5z and write it in terms of this expansion. I can write as 27y cube plus 125z cube as 3y plus 5z, that is x plus y, into 3y whole square minus 3y into 5z plus 5z whole square, which is the rest of the expression. This can be further simplified to be written as 3y plus 5z, 3y whole square is 9y square, 3 into 5 is 15 and y into z is yz, and 5z whole square will be 25z square. So I have now factorize this into the two factors given here. A similar factorization has to be done on the second question, which is 64m cube minus 343n cube. Here I can write this as x cube minus y cube, but from question 9 I know that x cube minus y cube equals to x minus y into x square plus xy plus y square. Here x cube is 64m cube and y cube is 343n cube. Now 64m cube can be written as 4m whole cube and 343n cube can be written as 7n whole cube. So x and y values are 4m and 7n. So I can write the given expression as 4m minus 7n into 4m whole square plus 4m into 7n plus 7n whole square. Upon simplification, this looks like this, which is 4m minus 7n into 4m whole square is 16m square, 4 into 7 28, m into n is mn, plus 7n whole square is 49n square. Now we have written the expression in terms of two factors using the derivation from question 9. 11th question asks us to factorize 27x cube plus y cube plus z cube minus 9xyz. This particular question is in the form of the identity x cube plus y cube plus z cube equal minus 3xyz, which is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Here x cube is 27x cube, y cube is y cube and z cube is also z cube. So I can say that 27x cube as 3x whole cube, and here because y cube is y cube, y can be written as y, similarly z can be written as z. However, x will be 3x. Upon substituting these values in this expression over here, I get 3x plus y plus z into 3x square plus y square plus z square minus 3x into y minus yz minus z into 3x. This can be written as 3x plus y plus z, 3x whole square will become 9x square plus y square plus z square minus 3xy minus yz minus 3xz. 12th question asks us to verify if x cube plus y cube plus z cube minus 3xyz is equal to half into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. Now we have to begin by simplifying the right hand side and try to see if the simplified version of this is going to be equal to left hand side. First step in simplification is to simplify the part within the brackets, which is x minus y whole square plus y minus z whole square plus z minus x whole square. Now I can use the formula x minus y whole square equals to x square minus 2xy plus y square in order to simplify all of this. So the first one will be x square plus y square minus 2xy, second one will be y square plus z square minus 2yz, third one will be z square plus x square minus 2xz. Now I have 2x squares, so I can write 2x square. I have 2y squares, so I'm going to write 2y square. I have 2z squares, so I'm going to write 2z square. I have 2xy, 2yz and 2zx. Taking 2 as common, I can write this as 2 into x square plus y square plus z square minus xy minus yz minus 2zx. Substituting this in the RHS over here, I get half into x plus y plus z into 2 into this expression. Here 2 and 2 gets cancelled and I am left with x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. From the identity, we know that this expression is equal to x cube plus y cube plus z cube minus 3xyz, which is nothing but the left hand side given to us. So we have verified that left hand side is indeed equal to the right hand side. Now 13th question says if x plus y plus z equals to 0, we need to show that x cube plus y cube plus z cube equals to 3xyz. Now we know that the identity says x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now we are given that x plus y plus z equals to 0. Substituting this value, I can get this as x cube plus y cube plus z cube minus 3xyz equals to 0 into the rest of the expression. So the right hand side will completely become 0. And I am going to send xyz to the other side. So this will become x cube plus y cube plus z cube equals to 3xyz, which is what we were asked to prove. 14th question says, without actually calculating the cubes, find the values of the following. First one is minus 12 whole cube plus 7 cube plus 5 cube. I can see that this is in the form of x cube plus y cube plus z cube. Here x is minus 12, y is 7 and 5 is z. Now upon calculating x plus y plus z, I am getting the value as 0. From our previous question, we know that if x plus y plus z is 0, then x cube plus y cube plus z cube should be equal to 3xyz. Using this logic, I can find the value of this by substituting x and y and z in 3xyz, which will give me 3 into minus 12 into 7 into 5. So I can write this as minus 3 into 420, which is minus 1260. Second one is 28 whole cube minus 15 whole cube minus 13 whole cube. Now x cube plus y cube plus z cube, where x is 28 and y is minus 15 and z is minus 13. X cube plus y cube plus z cube, where x is 28, y is minus 15 and z is minus 13. Calculating x plus y plus z, I get 0. So I can say x cube plus y cube plus z cube is 3xyz. So I can calculate this as 3 into 28 into minus 15 into minus 13. Minus into minus becomes plus, and 15 into 13 is 195. So I can write this as 3 into 5460, which is 16,380. In question number 15, give possible expressions for the length and breadth of the following rectangles with areas. So the area of a rectangle is given as a polynomial here. I know that the area of the rectangle is length into breadth. So if I factorize this polynomial and write it in terms of factors, I can identify the expression for length and breadth. So factorizing this using splitting middle term method, I have to first find the product of coefficient into constant, which will give me 300. So find two numbers that will multiply to give 300 but add or subtract to give minus 35. In order to do that, I need to look at factors of 300. I have listed some factors of 300 here. I need to find which of these two numbers either add or subtract to give me minus 35. So I know that 15 into 20 is 300, but 15 plus 20 is 35. So I can write 15 and 20 here and 15 and 20 here. So I need minus 35 but plus 300. So minus into minus will give me plus, but minus 15 and minus 20 will give me minus 35. Now I can split the middle term as 25a square minus 15a minus 20a plus 12. Taking 5a as common here, I get 5a into 5a minus 3, and minus 4 as common here, I get 5a minus 3. Taking 5a minus 3 as common, I can write this as 5a minus 4 into 5a minus 3. This is nothing but length into breadth. So the possible expressions for length and breadth are 5a minus 4 and 5a minus 3. Second question is another polynomial which is given as the area of the rectangle. We know that the area of rectangle is length into breadth. So if I factorize this polynomial, I'll be able to get expressions for length and breadth which we are asked to find. Factorizing this expression using splitting middle term method requires us to first calculate the product of first coefficient and constant, which is 35 into minus 12, which is minus 420. Now I need to find two numbers that multiply to give me minus 420 but add to give me 13, which is the middle term. How to do this? I need to first write down the pair factors of 420, that is the two numbers which multiply to give me 420. From this I can identify if any numbers are adding or subtracting to give me 13. After writing down, I came down to 15 and 28 whose difference is 13 and who multiply to give me 420. So I am going to write down 15 and 28 and 15 and 28. Here I need to get positive 13 but minus 420. So I will give the minus to the smaller number. So minus 15 into 28 is minus 420, minus 15 plus 28 is plus 13. Splitting the middle term and writing it as 35y square minus 15y plus 28y minus 12. Taking 5y as common in the first two terms and taking 4 as common in the second two terms gives me 7y minus 3 as common. So I can write this as 7y minus 3 into 5y plus 4, which is length into breadth. So the possible expressions for length and breadth are 7y minus 3 and 5y plus 4. 16th question asks me to find the possible expressions for dimension of cuboids if the volume of the cuboid is the given polynomial. So volume is given as 3x square minus 12x. I know that volume of a cuboid is length into breadth into height. So let me factorize this into three expressions in order to get possibilities for length and breadth and height. So the first step in factorizing 3x square minus 12x is to take out 3x as common. I have 3x into x minus 4. I can write this as 3 into x minus 4, which can be length, breadth and height. So the possible expressions for the length and the breadth and the height are 3x and x minus 4. Second expression gives me a polynomial for the volume of a cuboid. Second question gives me a polynomial for the volume of the cuboid as 12k y square minus 8k y minus 20k. Now, volume of a cuboid is length into breadth into height. Factorizing the given expression into 3 terms can give me the possibilities for length into breadth into height. Taking 4k as common, I can write this as 4k into 3y square minus 2y minus 5. Now, factorizing the inner expression will give me 2 more factors, and in order to do that, I need to multiply the first coefficient and product to give me minus 15. I need to find 2 numbers that multiply to give me 15 but add to give me minus 2, which is the middle term. So 15 can be written as a factor of 3 into 5. So I can write 3 into 5, that will give me 15, and the difference between 3 and 5 is 2. But I need minus 2, so I am going to assign the negative sign to the bigger number. Splitting the middle term gives me 3y square plus 3y minus 5y minus 5. And taking 3y as common in the first 2 terms and minus 5 as common in the second 2 terms will give me y plus 1 into 3y minus 5. So, the whole expression given to us can be written as 4k into y plus 1 into 3y minus 5, which can be the possible expressions for length and breadth and height that are the dimensions of the cuboid. With this, we have come to an end for part 2.4 Algebraic Identities as well as chapter 2.